Hello everyone, this is part of a lecture series where we are going over 2010 AIME math problems. In this lecture particularly, we will solve problem number 1. Here is a view of this problem. Maya lists all positive divisors of 2010 squared. She then randomly selects two distinct divisors from this list. Let P be the probability that exactly one of the selected divisors is a perfect square, only one. The probability can be expressed in the form m over n, where m and n are relatively prime in positive integers. Find the sum of m and n. We need to first start by figuring how many positive divisors 2010 squares might have. You can do a quick calculation to figure that 2010 is simply equal to 2 times 1005. Which in turn 1005 can be split. It is divisible by 5, so 5 times 201, and then you realize 201 is divisible by 3, so 3 times 67. Therefore 2010 squared would be simply equal to 2 squared times 3 squared times 5 squared times 67 squared. So it's not too difficult to realize that the total number of positive divisors of 2010 is simply equal to, you all remember the logic, so all we do is we add 1 to the exponents and then we just multiply them out, and that's it. So therefore from here we will get 3 to the power 4, which is simply 9 times 9, which is 11. So we know that 2010 squared has simply 11 positive divisors. But how many of these divisors turn out to be perfect squares? So one way to think of this is, well, we can definitely think of each of these 4 parts as independent perfect squares. So therefore we have 4 parts to 2010 squared. All we do is we decide how many of these parts we want to pick. Each individual part is a perfect square. A combination of these, like if you multiply 2 of them, they are still a perfect square, and so on. So as a result, we just realize that there should be, and also if you decide not to pick any of them, then that would be 1, and 1 is also a perfect square. So in the case you are picking none of them, plus if we are picking only 1, there are 4 different ways to pick one of these. And then there are 4 choose 2 ways to pick 2 of them, 4 choose 3 ways to pick 3, and finally 4 choose 4 ways, basically picking all of them. This thing would be equal to, well, there's a nice feature that you would all remember. So if you have a combination in that fashion, it would simply be equal to 2 to the 4, and then it gets us thinking if there was an easier way to figure out the number of number of different ways to pick a perfect square, and obviously there is one. So this reminds us that for these components, a perfect square divisors of this number will be of the form, so it will be of the form 2 to the, let's say, a times 3 to the b times 5 to the c times 67 to the d, that's a 7, where, let's write that down, a, b, c, and d are all either 0 or 2. But anyhow, regardless, so we got our number 16. So 16 of these 81 divisors of 2010 squared are actually perfect squares. Now the probability mentioned in the question would simply be equal to P equals, we have 2 options. So when we pick 2 divisors, so we might have either the first one we picked is a perfect square and the second one is not, or the first one is not a perfect square and the second one is not. So luckily, so once we do it, so what are the chances that the first one is a perfect square? 16 over 81. What are the chances the second one is not a perfect square? that would be simply 65, I believe. So those that are not, so it is simply 81 minus 16, which is 65, and then there's only 80 remaining. It might well have been that the first one picked is not a perfect square, which is 65 over 81, and I should say the second one is a perfect square, and there is only 16 different perfect squares, but only 80 divisors remaining. And that's it. So all you now do is to make this simple algebraic calculation. Luckily, the two terms are basically symmetric. They are similar, so you can simply eliminate one of them and multiply the other one by 2. So it would be equal to 2 times. And then let's focus on one of the expressions. Write down this expression one more time, and then let me do the algebra accordingly. So I will have 81 times 80. So from here, we will realize that, well, 80 is just 5 times 61. That reduces our problem significantly. And then 5 and 65 would cancel. So I would have a 13 remaining in the numerator. Oops, that's a 13. Okay, so therefore 2 times 13, which would be 26. And that divided by the remainder in the denominator, which is 81. So from here, you just realize that's obviously m over n. Okay, so from here we realize that m plus n is simply equal to 26 plus 81, which would give us 107. So that's the answer, and that completes our solution.